evening. So we would like to continue our talk from the previous Linaro Connect dedicated to testing automation of testing of OTP. Oh, thank you. And we would like to present some issues that we had in the last half a year, new findings, and present a new CI infrastructure that we started using during the since the last Linaro Connect, basically. So, Maxim from Linaro will continue, and Dmitry from Kevin, and will also step up in sometimes.
Thank you, Dmitry. A few words about what is ODP. Is my mic working? This talk will be about CI on ODP, but actually this environment, this setup or ideas are related to any project, so you can easily take our environment and replicate it to your project. So ODP is open source project. It's hosted on GitHub, and the idea of the project is a set of networking API to accelerate your networking applications. The project is written on C99 language, and it's done for different architectures. So ARM, MIPS, PowerPC, x86, and whatever. To test OTP, we use really big infrastructure, so it's Travis and Shippable. And later we will show the different options and how to use it.
Okay, so now back to to test environment. Basically, what OTP provides is a set of API. The reference implementation and one of the most priceless parts of OTP distribution is the set of tests to validate different vendors' implementations. To actually check that what vendor has provided to you is compatible with the implementation, with the specification. So initially we started to use Travis CI. Travis is a free continuous integration platform. It is tightly integrated with GitHub. It allows you to test your public projects, public repositories for free. It provides a rich set of features like scriptable task descriptions, supports running up to 5 parallel builds in the free default mode. It has networking access. It allows you to run applications under root, etc. So it is really big, it is useful, and it's really easy to start. You just put a simple Travis UML file into your project root and you're done. Just punch the switch on Travis and it will be testing your software. Travis runs on each, can be set up to run on each Git push to your repository, be it master branch, be it the tag push, be it the pull request, and using it for pull requests is extremely useful because you can run the same set of tests for the pull requests. You can actually check that at each time you will not break the software by merging this and this set of patches. You already know that in advance too. For the stable branches, so you can set up a cron job to run tests regularly, so that if your software depends on some external pieces of software, on external infrastructure, you can be sure that even if you didn't touch that branch, it's still working. For example, we use cron jobs to actually check that different branches of ODP are ABI compatible or not ABI compatible between each other. We just have a separate repository running the ABI check scripts. Okay. So, how to apply Travis CI to your job? As I said, the start is really simple. .travis.uml. Basically, the next step is to provide a build matrix. There are two ways to specify build tasks, what to do, which test to run. First way is traditional to CI, well, actually, second way is traditional to CI systems. It just provides a list of all the tests that to run, a list of different scripts to run. First one is, I think, was innovated by Travis. It allows you to specify metrics. You can set which compilers to use, which Ruby versions, which Java versions you use, Java, etc. And multiply that in different environment settings. So you can specify that, okay, I want to run this compiler, for example, we use GCC and Celan, and we specify that for each of these compilers we want to run the same set of tests for different configure options. So this way we assure that different ODP distributions, different ODP versions that we build, that we support, still can execute the same set of tests. It is possible to employ cross-compilation, or we use that to actually check that our software compiles for different architectures. We run cross-compilers for ARM, for ARMv8, for PowerPC, and of course for x86. Each additional test, each additional feature is as a separate job. You don't have to squeeze all the tests, all the possible invocations, all the possible options into a single continuous integration script. You just define different tests, and they will be executed parallelly. Switch to the slide. Okay, an example of the test matrix, as I said. Here we see two compilers, GCC and Celan, two different environment settings. First is to build API compatibility mode. Second is to build with default config options, but for the different DPDK versions. This is a part of our EML script, but this is to show you. And then comes, for an example of the completely separate job that is built for ARch64, that uses different compiler, that uses different environment settings, and in fact it uses even its own build script to execute only cross-compilation. So, unfortunately, the light is too strong in this room, but this is a list of all the different options that we employ, a lot of different tests that we employ. A fast set of the compile-only tests to catch easy mistakes like, oh, I forgot to commit this file, and oh, I forgot to push this branch in its own state. And then a set of tests doing the full set of cross-compilation, a full set of tests with different configure options, etc. Next.
Yeah, so idea of the test is to test all possible combinations and all possible variations of build of application. So on this picture, I try to show what exactly we test. So we have a DB project, and we test different targets. It's code coverage, doxygen documentation. We test patches, we check installations, and we check source code with a validation test. We do different compilation with GCC and CLang. We do performance test and examples. And we want to test it on different architectures. ARM, ARM64, x86, x86, 64, PowerPC. So there are a lot of different variations of doing test, and test takes a lot of time. So we need to run these tasks in parallel. And if we add more tests, like on the next slide, for example, we have different configure options which came after a project started growing, and we want to test different tool chains, and we want to also test that our code works on MIPS. Then we have much more bigger configure options and build variations, and this is increasing build time. So as ODP is open source project, our target is that everybody can download project and compile it and run on their machine, on their hardware station. And sometimes we don't know what is compiler version and what tool chain people use. So we are just trying to make ODP workable on the most popular environment, like fresh version of Ubuntu, stable version of Ubuntu, or some stable version of OpenEmbedded. When we started with very simple matrix. So we just had Clang and GCC and 4 build matrix just to compile everything, make tests, and check oxygen and check patch hunting. That's what's all. After that, we started to add more tests like cross compilation. We added different configure options, different architectures, new targets, and our build took 4 hours. If we collect all small tasks, which we can run in parallel to one long task, it will take 4 hours. Now, our test takes 8 hours and 27 minutes. So actually, because we do it in parallel, we do it less than 1 hour, but all build is really long. We do a lot of optimization, which Travis allows. So one optimization is C-cache. So it allows you to cache compiler's object even on the new runs. So and to use C-cache on pull request and to use it on validation branch. And our optimization, it's pre-built cache for dependencies. For example, ODP depends on different applications like CUnit, which we use for test, and we don't need build CUnit on each ODP build. So we build it only once, and if a version of CUnit, for example, will change, then we will rebuild CUnit. The same with our regressions. Travis also linked it with GitHub, and GitHub with project named Coverity. So they work together, Travis, GitHub, and Coverity. And Coverity allows you to get code coverage for free. So the same web interface, which is linked to GitHub, and on each pull request, on each run, you can navigate to code coverage link and see which line, how many runs were executed. So it's a very useful tool just to find some functions which are not more used in the project.
Okay, so now we want to switch to another CI tool that we started using recently. On the previous talk we introduced Travis. Now we want to introduce Shippable. And the reason why we now have 2 different CI tools is that none of them is perfect. As I said, Travis executes all build stages only on x86-64 build machine. We do cross-compilation, but using Travis doesn't allow us to run tests on actual RH64 boxes. We would like to test our software on other platforms. We are supporting them as our primary targets. So that's why we also started using Shippable, because Shippable also allows you to plug your own build nodes. Well, at this moment only ARM-V8 nodes, and to use them as you build host, to build your software, to build and run your test scripts. Shippable through magnifying glass. It is either x86-64 or AH64 architecture. It also uses YAML config, but unlike Travis, it allows you to actually configure the Docker images that you run your tests on. unlike Travis, everything is always run as under root privileges. So we don't have to care about sudo. We don't have to care about access to different network interfaces, about getting sudo to install additional dependencies. It always comes for free. It has the same build matrix concept as does Shippable, so we basically were able to copy and paste a significant part of our Travis setup to Shippable. At this moment, it doesn't have extra build stages, but I think they're going to introduce that soon. They have a visual representation for test results, unlike Travis for code coverage. We'll show that in the next slides. And unfortunately, unlike Travis, they are more greedy. They allow you to have one build node, so no parallel builds, and you actually have to pay to get more build nodes, even just to get second build node. For now, we have simple two build metrics, so only CLang and GCC, and just ABI compatibility, non-ABI compatibility mode. What it means for you is just different ways to either inline API functions into the ODP code or not to inline and to have them as separate functions. So tests are not parallelized. Performance tests are disabled to speed up builds because otherwise it will take too much time. So this is the example of the test results. It is a test of the PR pull request. You see that it has an interface to show how many tests have been passed, how many tests failed. Here we can see not only that the build stages have failed, as you would see in Travis, but also how many tests were executed, how many failed, and if you go into the build details, you will see which tests and which lines have failed. And for the last build that failed early, there were no tests executed, so it shows that there was no test data.
Future steps for this project. Of course, we want to improve validation time to make it as smaller as possible, because people don't want to wait forever while pull request will be tested. So if a reaction will be in 20 minutes, then it's acceptable time. We want to use Travis and Shippable, but this functionality is not enough for us. We want to do also performance tests. And to make performance test, it's especially for networking, it's a require additional environment. So we just need isolated network, isolated CPU cores, and isolated task on this CPU core. So we just need more control on infrastructure to do some predictable tests. So we want to use special hardware for which we support in ODP. And we want to test different ODP implementations also. So, and these implementations also are linked to different hardware.
So these are our future steps. They are not solved with the current infrastructure of using both Travis and Shippable. So we are looking for yet another CI infrastructure. It might be Lava, it might be something else, but this is our future. This is what we are looking for.
And summary of our work for CI is that first that we don't need git bisect to find where was the problem. We know that special commit which is accepted to the project was validated, and we see that it was validated inside pull request, and we see that it was validated inside the branch itself. So we do double testing, and we just can jump to that commit. For that approach, we do not have last minute bug fix. That means that we need to do release and somebody merged something and everything is broken, and we need to understand which commit broke what. We just know that exactly that our project can be built and run on that stage. Our test infrastructure can be easily reproduced to local builds. So on GitHub you can fork our project and you will have the same infrastructure for your own local ODP repository. So maintainers review patches just after code was validated by CI scripts. So that saves some maintainer time to look to typical problems, or at least it's much more easy to point to check patch issues and the issue which what our test can find. By placing tests inside the project, we have contribution to the test itself. When it was one test built in separate project, then only LNG team supported development of test scripts itself. But now we have a contribution to test scenarios also. So that's actually all. You have something better?
Yeah.
Yeah. Thank you.
Thanks. Any questions?
This should be fine. So I have multiple questions.
Yeah, otherwise nobody will be able to hear you.
No, that's perfectly fine.
No, it's not.
at all. So for the performance pieces, the problem that you have today is it's more on the shippable side. Is that correct? Where you can't test on bare metal, or you don't have like ice. Well, all right. For the problems that you outlined that you have today, is it more on the shippable side than on the Travis side?
Up to some point, because both Shippable and Travis use virtualized environments, and thus when we run tests, we don't have full control of what else is run on this node, on these views, etc. So Shippable uses Docker. Travis uses its own virtualized environment. I think it also uses Docker or containers up to some point. So we use containerized builds, yes, because we use sudo. But yeah, the problem is that we don't have full control over the system, so we cannot predict the performance of the build node. We had one of the tests failing randomly because it checked the actual performance, it compared the actual performance of the system, and the results of that test were not stable enough to be able to feed them into the some margins that we can set up in advance. So then we had to disable this test for the CI environments because it's not stable enough.
Okay. And are you testing 32-bit and 64-bit?
Yes.
Okay. And then for that, where you can supply your own node in Shippable, did you guys try that feature set or no?
We supply our own RMV8 node to Shippable, so yes.
Oh, okay. And did that work for you for the performance test, or it was still virtualized on top of your own node?
It is still Docker on top of our own node. Okay. So Shippable uses Docker to run the tests.
Got it. Okay. I'll probably have more questions, but go ahead.
I was just going to elaborate the answer to one of your questions,
Sure.
which is this is specific to what we're doing with ODP, is that ODP has a number of APIs that are specifically designed to control timing aspects of platforms. And so testing those, to say, when you say I want to set a timer for X milliseconds or nanoseconds or whatever, and I'm trying to validate that in fact you actually hit those targets, that's where the challenges come in these virtualized environments, because that's not the intended use of those APIs in a virtual, it's really in a more embedded environment. So I think one of the things that we're looking at is how to better do performance-sensitive testing in these environments as opposed to just functional testing. Okay.
Yeah.
With your own dedicated node, do you still, like, I know it's in a virtualized environment, but it's a container, and you should be able that it's not like a hypervisor, so the performance should be.
In theory, yes. In practice, no.
Okay.
So even in practice, there can be different latency issues with the Docker on our own node. So we have faced them, and we had to disable this traffic manager test pick, and we had issues with the terminal tests on the both on Travis and on Shippable. So it's not only related to Shippable. The other reason why you will see that we had performance test disabled in Shippable configuration is that currently Shippable full tests run 1.5 hours of wall clock because we have lots of tests, so it takes too much time. And enable performance tests will boost that significantly. So for now we have disabled performance-related tests like on Shippable because we only use Shippable to actually check that our software works on the ARM64 and ARM8 architecture. We do not really have to check that it meets performance constraints because that is tested on the x86 performance. It means not only the throughput of packets but also latency, timers, etc. So, yeah, I saw the question somewhere from.
Yeah, but I think you're running out of time.
We're out of time.
Mostly in comment, I will just come to you.
So you can ask questions after the talk in private, that we would be happy to answer. Thank you.